Using a simple set of magnets, MIT researchers have come up with a sophisticated way to monitor muscle movements, which they hope will make it easier for people with amputations to control their prosthetic limbs. In a new pair of papers, the researchers demonstrated the accuracy and safety of their magnet-based system, which can track the length of muscles during movement. The studies, performed in animals, offer hope that this strategy could be used to help people with prosthetic devices control them in a way that more closely mimics natural limb movement. These recent results demonstrate that this tool can be used outside the lab to track muscle movement during natural activity, and they also suggest that the magnetic implants are stable and biocompatible and that they don't cause discomfort, says Cameron Taylor, an MIT research scientist and co-L. In one of the studies, the researchers showed that they could accurately measure the lengths of turkeys' calf muscles as the birds ran, jumped, and performed other natural movements. In the other study, they showed that the small magnetic beads used for the measurements do not cause inflammation or other adverse effects when implanted in muscle. I am very excited for the clinical potential of this new technology to improve the control and efficacy of bionic limbs for persons with limb loss, says Hugh Hare, a professor of media arts and sciences, co-director of the K. Lisa Young Center for Bionics at MIT, and an associate member of MIT's M. Tracking movement. Currently, powered prosthetic limbs are usually controlled using an approach known as surface electromyography, EMG. Electrodes attached to the surface of the skin or surgically implanted in the residual muscle of the amputated limb measure electrical signals from a person's muscles, which are fed into the prosthesis to help it move the way the person wearing the limb intends. However, that approach does not take into account any information about the muscle length or velocity, which could help to make the prosthetic movements more accurate. Several years ago, the MIT team began working on a novel way to perform those kinds of muscle measurements, using an approach that they call magnetomicrometry. In a study published last year, the researchers showed that this system could be used to accurately measure small ankle movements when the beads were implanted in the calf muscles of turkeys. In one of the new studies, the researchers set out to see if the system could make accurate measurements during more natural movements in a non-laboratory setting. To do that, they created an obstacle course of ramps for the turkeys to climb and boxes for them to jump on and off of. The researchers used their magnetic sensor to track muscle movements during these activities, and found that the system could calculate muscle lengths in less than a millisecond. They also compared their data to measurements taken using a more traditional approach known as fluoromicrometry, a type of X-ray technology that requires much larger equipment than magnetomicrometry. Thanks for watching. Please subscribe my channel for more videos.